Hello and good day everyone. Welcome to Civil Engineering Software's application CE 4151, and in today's video we would be discussing about the introduction to STAAD.Pro and the basics in modeling. So what is STAAD in the first place? So for starters guys, aside from the definition that is stated in this part right here, STAAD basically is a computer software developed by Bentley Systems used to analyze and design various structures. So that is STAAD in a nutshell. But if you want to learn more about STAAD as per its definition, you can just go straight to this website right here, which is bentley.com/en/product/brands/STAAD. So once again, that is STAAD in a nutshell. So STAAD has these different products that a civil engineer can use. So we have here your STAAD.Pro, STAAD.Pro Advanced, Structural Work Suite, STAAD Advanced Concrete, STAAD Foundation Advanced, and Microstrand among all things. So there. But for this module guys, we would be focusing on STAAD.Pro. So what is STAAD.Pro? So once again, aside from this definition that is stated in this part right here, STAAD.Pro basically is the most basic STAAD option, and it includes physical modeling. So I would just be writing them here. And FEM analysis. So FEM analysis. So once again, STAAD.Pro is the most basic STAAD option, which includes physical modeling and FEM analysis. So what is FEM analysis right here? So FEM stands for finite element method. So what is this finite element method right here? So this method is a method used in various differential equations wherein you are to subdivide a certain entity into smaller, simpler parts. And these smaller, simpler parts right here, which are to be our elements, are the elements that our program will analyze. So for you to understand it better, let's just draw a sample right here. So for pretend that we have here your column. So let's say that this one right here is a column. Say that this one right here is a beam. This one right here is a beam and another column here. So in FEM, once again, what we are to do here is to subdivide the certain entity that you are analyzing. So let's say that this is to be one division or one element. So this is to be your first element. This is to be your second element. Let's say this is to be another element, and so on and so forth up until you reach this element right here. So once again, these are to be the elements that our program will analyze. So this FEM right here is rarely used in common manual engineering computation since it is very time consuming. So just imagine that you would be getting this element right here and you would be solving it. Then you would be getting this element right here once again and solving its results and whatsoever up until you reach at this part right here. So from that itself, it is already very time consuming. So what we typically do in manual computations is that we would be getting one critical portion of a structural member, and that is to be our basis in most of our designs. So that right there is a very conservative approach, a very fast approach, but not really the most economic approach. And in STAAD.Pro, so STAAD.Pro is a program that will help us analyze finite elements without compromising our time. So with the help of your computers and STAAD.Pro, you can now solve for the stresses of every element that is in your structure. So may it be this element right here, this element right here, and whatnot. So in this module, everyone, we would be discussing about the basic fundamentals of the program, which are typically used in designing vertical projects. So there. Okay, so after installing STAAD via education.bentley.com, this is what STAAD.Pro would typically look like. So the first time that you would be opening your STAAD programs, you would be welcomed by this interface right here. So if you already have your saved files with you, you can see them here. And if you want to open them, just click them. So there. But in this video, we would be making a new model. So to create a new model, just click here, click new. Then you would be welcomed once again by this interface right here, and I would be typing our file name here. So let's say that this is to be SLU modeling tutorial. So let's say that that is to be my file name. And as for the location, so you must choose the location where your STD files will be saved. So there, and click here, analytical. And since we are in the Philippines, I would be choosing metric units as our base unit. So that is to be in terms of meters, millimeters, and whatsoever. So metric. And as for the titles here, so if you want to include the title here, just type them here. And if you want to have a model seed file, you can browse them here. But in this video, we would be starting from scratch. Okay, so there. And next up, we must click here, job info. So if you have your necessary details here, I mean, if you want to fill this up, it would be up to you. So let's say that our job name is to be SLU tutorial or SLU modeling tutorial. Just type them here. And for our client, let's say SLU students and whatsoever. So job number, it would be up to you to fill this up right here. So the next thing that you would be doing is to click create. So once clicking create, you would be arriving at this interface right here. So we have here your toolbars. So as you can see, we are in the geometry toolbar right here. I mean the geometry tab. So in this geometry tab, it is where you can start with your modeling journey. I mean STAAD modeling career, I should say. So we have this plenty of ways to start with your modeling. The first one is to import your DXF file. So let's say that you have drawn a certain model using a CAD software in the format of a DXF file, you can upload them with this method. Just click file right here. Then as you can see here, which I could not. So here, import/export. Oops, I'm sorry, I'm blocking the way. So as you can see in this part right here, import/export. Click here and import DXF file. So you can do this if you already have your DXF file with you using your CAD software, but I do not. So let's go back here. So another way on how you would be making your model is to be this structure wizard right here. So this structure wizard would give you some pre-made structures. So as you can see here, if you want to have a prot truss, so just click here. So once again, I would just be moving my face. So there, so click here at this prot truss right here, and it would ask you the dimension. So let's say its length is to be 50 feet, its height is to be 10 feet, its width is to be in 10 feet, and let's say that I want the number of base to be 4 and whatsoever. Click apply, and as you can see, I already have my prot truss right here. So if I would be clicking escape here, STAAD would ask me if I want to transfer or merge this prototype into STAAD.Pro. So the moment that I would be clicking yes and okay, our structure is already done right here. But in this video, we would be doing it from scratch. So let's have a certain problem first. Okay, and for us to start with our modeling career or our modeling journey, let's have a certain problem here. So let's do this instead. So create a model of a 3-story building given the typical floor framing plan. So meaning that in every floor, it would be having this floor framing plan. Okay, so as you can see at the right side, this is to be 3 meters, 1.8 meters, 3 meters, and as for the top one, this is to be 4 meters, 4 meters, and 4 meters. So there, and using those, we would be modeling them here. So let's just display our model here. Okay, so by the way, guys, we have this sign convention right here. These are to be our axes right here at this part right here. So as you can see, the positive x is going to the right, your positive z is low-key going towards you, and the positive y is going upwards. So for you to understand it better, let's say that this is to be your positive x-axis, and let's say this is to be your positive y, and let's say that this is to be your positive z. So it would be as simple as that if you didn't see what is being shown in our STAAD program. So going back once again to our STAAD program. So as you can see, this part right here is to be the thing that I was explaining to you a while back. So what we would be doing is that we would be creating the 3-story model of this certain floor plan right here. So what we would be doing is that, so let's say that this is to be our origin at this point right here. So what I would be doing is that I would be creating a node at that point. So what is a node? So in STAAD, a node is a joint in which by default has 6 reactions. And if you want to model a beam, you must first define the location of the nodes where you will be locating your beam. So you cannot draw a beam without nodes. Okay, so let's draw a node first. So let's say that the first node, which is at this part right here, that is to be 0, 0. So I would just type our first node here, which is 0, 0, 0. So as you can see at this portion right here, you already have one node. So let's say that our next node is to be this joint right here. So that is to be in the x-axis, that is to be positive 4. In the y-axis, that is to be 0. And in the z-axis, also in 0. And once that I have typed that already, we already have these two joints right here. I mean, two nodes right here. And as for the third node, which is this one right here, this one right here has a coordinate of 8, 0, 0. So from that, I would just be typing here 8, 0, 0. And as for the last one, this is to be 12, 0, 0, since 4 plus 4 plus 4 is to be equal to 12. So 12, 0, 0. So as you can see, I already have this 4 right here. Okay, so as for these joints right here, so this part right here has a coordinate of, so in the x-axis, that is to be 0. In the z-axis, that is to be positive 3. So as you can see here, this is 3. So we're going to the positive z direction, that is to be positive 3. And we are still at the same plane, so our y is still 0. So from that, this is to be 0, 0, and this is to be 3. So once entered, as you can see, this one right here is basically this one right here at your lower left corner of the screen. So this one right here. So there, and I would just be assigning the nodes here. So there, and as you can see, I already have these nodes right here, which is at the same locations as of these columns right here. So there, and whenever we start our construction, we always start with the foundation or the footing. So since that these locations right here or these joints right here are also the location of our footing, let's assume that these joints, I mean these nodes right here, are for the footing. So the next thing that I would do right now is to copy these joints right here at a certain elevation. So what I would be doing is that click here or click select right here. After clicking select, click here, which is node cursor. So what this does is that once activated, and let's say that you would be selecting this one right here, you would only select the nodes and not the beams, not the plates, only the nodes. So there, and as you can see, this one right here is already highlighted red. So now that they are selected. And the next thing that I would be doing is that click here on the geometry part or the geometry tab. Then at this icon right here, so this is to be our translational repeat. So translational repeat is kind of similar with the offset command in your AutoCAD. So once clicking here, so it would be asking you the step. So let's say that our footing is 1.8 meters below the ground. So just for pretend, I would be copying these joints right here at a spacing of 1.8 meters upwards. And that is to be our ground level already. So what I would be doing here is that I would be clicking Y direction since I want my offset or our translational repeat to be going to the positive Y direction. So click Y. Then after which it would ask you the number of steps. So the number of steps is that how many times it would copy the nodes that you have selected. Okay, so I would just be choosing 1. And as for the step spacing, like what I have said earlier, that I want my footing to be located 1.8 meters below the ground. So meaning that I would be copying these nodes right here 1.8 meters upward. So positive 1.8. And I don't need to indicate positive here since 1.8 is basically positive 1.8. And there is also this part right here, which is this checklist right here saying link steps. So what this does is that after copying your nodes, it would now link them with a beam. So let's say that I would just be clicking OK right here. As you can see, the node is now copied upwards, if you can see. And I would just be undoing it for you to see the difference if I would be linking the steps. So once again, I would be selecting them with our node cursor, click our translational repeat right here. Then as for the default spacing, 1.8 once again. The direction is to be the Y direction. And I would now be clicking this link step right here. So once I click OK, as you can see, it already copied the node vertically upward with a distance of 1.8 meters, and it is already linked with a beam. So guys, what is a beam, by the way? So in STAAD, guys, when we say beam, beam is any member in the structure. So it does not entirely mean that it is a flexural beam. So when we say beam, that can also be a column, that can also be a truss member, an axial member, a bracing. So all members here in STAAD are called beams. So even though that this one right here, so even though that these members right here are columns, they are still considered as a beam. So, okay. And by the way, guys, when you click view here, you can view this model right here using this views right here. So if you want to view the front view, so click front view. So you would be seeing the front view, the side view, and if you want to view at an isometric view, it would be this one right here. So that is what we have been doing a while ago. Okay, so what if I only want to view this one right here, or this upper nodes right here? So let's say that I want to view this node, this one, this one, this one. And so let's say that I want to view the nodes located in the ground floor level, not including the foundation level. So just click all the nodes, then click here on view, click view, then view selected object. So once that I would be clicking this, it would only show the selected nodes that I have selected. So once again, if I click this, as you can see, the nodes at the foundation level are already hidden. So with that, it would be easier for us to model our structure right now. So for us to create a beam, so create beam, so once again, just click here in this geometry tab right here. And as you can see here, there is this thing called add beam. So click add beam. So there. And for you to add your beams, click at one node, then click at the next node. So it would be as simple as that. And as you can see, we already have our beam there. So if you want to have a beam here, just click at this node right here, then click on this node, click on this node up until you complete this particular structural plan right here. But guys, it is better for you to make it as a practice that when you are to draw your models, you do it from your origin going towards the direction that. So let's say that this beam right here is going to the positive z-axis. So it is better for you to model it like this instead of the other way around, instead of doing it from here to this point. So I would be explaining that to you soon, why it is better for you to be accustomed to that practice. So once again, from the origin going to the positive z-axis, so here, and from this part right here going to the positive x-axis, at this point right here going to the positive z-axis, and whatsoever. Okay, so now that I have already modeled our ground floor framing plan, so let's say that I want to view now the whole structure that I have created. Just go to this tab right here, which is the view tab, then click here in selected objects. View selected objects, so click that, and it would ask you that no object has been selected. Just continue, then click here once again. And once you click that, you can now view the structure that you have created. So there. But once again, looking at the lower part of your screen, we are to create a 3-story building. Aside from the foundation, we have the ground level plan. We also have the second floor framing plan. We also have the third floor framing plan. And we also have the roof beam plan, or the roof beam framing plan. So what I am going to do right now is instead of manually inputting the nodes here, I would just be making use of the translational repeat command. So what I am going to do right now is that I would be selecting all of these entities in the first floor framing plan, and I would be repeating them at the positive y-axis. So there, so let's just do that instead. So instead of selecting them one by one, what I am going to do is that I would be going to the front view. So if I click here in the front view, which is this one right here, I can now select these objects right here. And after selecting those objects, once again, go to geometry, click translational repeat, then we would be copying them along the positive y direction. So this one right here. And this time, the number of steps would be 3, since we would be copying it for the second floor, the third floor, and the roof beam framing plan. So we have 3. So the number of steps would be 3. Okay, so though it is not indicated in the problem what is the floor-to-floor height of your structure, let's assume that it is to be 3 meters. So there, so once clicking this one right here, as you can see, the first step is to be 3 meters, the second step is to be 3 meters, and the third step is also in 3 meters. So the question is, are we going to link the steps? So basically, yes, if we want the STAAD to automatically draw the columns. So if I would be clicking these link steps right here, then pressing OK, as you can see, this is now our structure. And it's isometric view. So click view, click this part right here. So this is already our structure. But take note guys that if you would be making use of this translational repeat right here, is that if you would be clicking these link steps right here, so suppose that you have another joint that, let's say, that does not include any column, he would assume, or the program would assume, that that joint would also be the location of a column if you would be doing the same method that we did. And by the way, guys, instead of clicking these views right here, the isometric view, this is to be the top view, this is to be the front view, this is to be the left side view, and whatsoever. So from your isometric view, you can also make use of your arrow keys to rotate your model. So if I would be clicking the down, the down bottom, it would be like this, and there. So it would be up to you on how you would be experimenting them. So that is it for our first video among many videos that would be uploaded in our stream. So thank you.